Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. Okay, in this slide we are going to discuss on linearity of a system. Okay, linear system is a system whose output is proportional to its input and it satisfies the following properties. Okay, the additive properties. When the input being added with another input, so the output also will be added together. If the signal being scaled by a variable k, so at the output point, the output also being multiplied or being scaled by k. And it also fulfills the superposition properties, in which it includes the additive and also the scaling property. And this can also be called homogeneities. In order to determine whether the system is linear or not, so you need to consider two systems, in which the first system as shown on the left hand side and the second system as shown on the right hand side. So the first system having the input x1 and x2 that being added together, and then both of them being processed, the added signal being processed in a system, and then the output YA being produced. In the second system, you have both x1 and x2 again as the input, but each of the signal x1 and x2 being processed individually, and then both of them will be added at the end and the output YB is produced. Then YA, this YA and YB will be compared. If YA equal to YB, then the system is linear. If YA is not equal to YB, and so the system is nonlinear system. Okay, so in order to determine the linearity of a system, so you need to consider three input variables, which are x1t, x2t, and also x1t plus x2t. Okay, the first step, you need to determine the y1t if the input is x1t. The second one, if the input now is x2t, so determine y2t. And the third step, you need to determine y prime t if you add both y1t and y2t together. Next step, you need to determine y double prime t if the input now is x1t plus x2t. And the last step, you need to compare both y prime t and y double prime t if y prime t equal to y double prime t, so the system is linear. Or else, if y prime t not equal to y double prime t, so it is a non-linear system. Okay, so you need to perform these steps in order to determine whether the system is linear or non-linear. Okay, let's look at this example. So you need to perform the steps as shown in the earlier slide. So you need to determine y1t if the input is x1t. So given the equation equal to yt equal to txt. So now if the input is x1t, so your y1t equal to tx1t. Second step, you need to determine y2t if the input is x2t. So in this case, using the same general equation, So now your y2t is equal to t. Now the input is x2t. Okay, next step, the third step, you need to determine y prime t, in which it is equal to y1t plus y2t. So what is your y1t? It's tx1t. So y prime t equal to y1t plus y2t, in which it is equal to tx1t plus tx2t. So this one can be simplified to tx1t plus x2t. This is your y prime t. Okay, next step, determine y double prime t if the input now is x1t plus x2t. So y double prime t equal to t. So now your input xt becomes x1t plus x2t. So x1t plus x2t. So last step, you need to compare y prime t and y double prime t. So in this case, y prime t equal to t x1 plus x2t, and y prime double prime t equal to this. So in this case, you notice that y prime t equal to y double prime t. So the system is linear. Okay, let's look at the second example. So again, follow the steps as discussed earlier. So determine y1t when the input is x1t. So now y1t equal to 10xt equal to x1t plus 5. Second step, x2t, you need to determine y2t. So y2t equal to 10x equal to x2 in this case, so x2t plus 5. The third step, determine y prime t. So you need to add both y1 and y2. So y prime t equal to y1t plus y2t. So in this case, it is equal to 10x1t plus 5 plus, so this is your y1t plus 10x2t plus 5. So in this case, y prime t is equivalent to 10x1t plus x2t plus 10. So this is your y prime t. So next you need to determine y double prime t, in which x now equivalent to x1 plus x2. So y double prime t equal to 10. Your x now is x1 plus x2 t plus 5. Okay, next, finally you need to compare y prime t and y double prime t. So in this case, you can notice that y prime t is not equal to y double prime t. Why it is not equal? Because okay, you may notice it's the same in this part, but at the end y prime t you have plus 10, but y double prime t you have plus 5. So the system is non-linear. Okay, let's look at another example. This is for discrete time signal and system. Okay, the first step, as usual, determine y1n. So y1n equal to x equal to x1n plus 2x1 n minus 1. Then determine y2. So in this case, y2n equal to x2n plus 2x2 n minus 1. The third one, add them up. So y prime n equal to y prime n equal to y1 plus y2. So x1n plus 2x1 n minus 1. This is y1 plus y2 is x2n plus x2n minus 1. So this is what your y prime n. Next, determine y double prime n. So y double prime n equal to your xn becomes x1 plus x2. So this one is x1n plus x2n plus 2. So x1n minus 1 plus x2n minus 1. So this is your y double prime n. So if the final step is to compare y prime n and y double prime n, so you can compare each component. So in this case, you have xn, you have 2x1 n minus 1, 2x1 n minus 1, x2n, and plus 2x2 n minus 1. So 2x2 minus 1. So in this case, you notice that y prime n is basically equal to y double prime n. So obviously the system is linear. Okay, another example, again in discrete time signal. The first step, y1n, so y1n equal to, so in this case it's x1n squared. Okay, please don't forget this one is equal to xn squared. Okay, so next y2n, so y2n equal to x2n squared. Third step, determine y prime n, so y1 plus y2. This one equal to x1n squared plus x2n squared. Next, determine y double prime n. So in this case, x1 plus x2. So y double prime n equal to x1n plus x2n. So this is your xn and then being squared. So this is you need to expand the equation in order to compare with y prime n. So finally compare both y prime and y double prime n. So you should notice that this y prime n is not equal to y double prime n. So in this case, the system is non-linear system.